about the block diagram, code, and the protein circuit of the project, or we can say offline solver and obstacle detector. So we'll start with the block diagram of our project. So basically we have used a microcontroller 8 82560 Arduino, and in this we are going to use some sensors here like current sensor, voltage sensor, encoders, U sensor, and also SD card. The basic purpose of this project is to detect the line. Basically, first of all, that is detect by the IR sensors, and the next thing this project have to do is the U sensor, ultrasonic sensor. Ultrasonic sensor detect the if there is any obstacle there. If there is any obstacle, then the robot detect that obstacle and take a U-turn and get back to the path from where it's come. But in all that, we have two major things. As we know that for moving the motors or to perform some work, we need motors here. So these are the motor left and motor right. But these motors have some voltage, current, or some speed that goes inside or flowing across the circuit. So to detect that, we added some current sensor and voltage sensor here. Further on, we add two more things, left encoder and right encoder. These two are defining the speed. At the end of this video, I am going to show you the hardware functions in which the LCD shows all the data of current, voltage, encoders, RPM, and so on. And the last, the most important thing is the SD card here, which stored all this data inside it. Now, let's get detail into this circuit here. Now, I'm going to show this circuit detail with this code here. So, the code here is this. So, I'm going to show you it with this my diagram. So, this is the diagram, and this is my code of Arduino IDE. Further on, let's get into this. We include three libraries. The include is for the LCD here. The further onward is let me adjust it first so I can explain it properly. Here you go. So the first library we include header file of LCD. The next is for the SD card, and the for the SPI for SD card too. Further on, we have the pins defined here for our. The first 6 are for the IR sensor here. IR sensor going to get some input, and goes it that input is delivered in the Arduino, and it gets data that whether it detect high or low, and according to that high and low we perform functions of motors. Further, these 6 pins are for the motor drive modules here. So in the motor drive module we have some 3 pins here. In the center there is a ground. I have excluded it in the block diagram, but it is there. Further on we have these pins. These 4 pins are for the direction control of the motor, whether it have to move the clockwise or the anti-clockwise direction. So by changing these pins out2 to out1 or out1 to out2, which clockwise and anti-clockwise direction is assured. We can change this direction from reversing these pins or changing these lines, or we can also change these input 1, input 2 for this motor, and iron 3, iron 4 for right motor. Further on, we have 2 pins also here like enable 1 and enable ENA, ENB. Onward, these are for the motor's active pins. Further, these are the motor active pins, or we can say that these are the PWM pins of the motor left and motor right. Further on, these pins are defined for the ultrasonic sensor. This is defined here like echo and trigger. So some kind of data is transferred to this and the echo is provided to this ultrasonic sensor so detect the object. Further on, these are the pins we defined for the SD card here. I am going to show you this SD card here. So this is MISO. Here is some mistake, sorry. So MISO, MOSI, SCK and CS. So these are specific pins which cannot be exchanged and as it is for the single communication, so it is reserved pins. Further on, the next thing is our encoders, also known as U sensors. These sensor purpose are to detect the RPM of motor. So for that, I define the pins here. IO for one encoder 20 and the other encoder 21 pin. Further, when I am going to show you its code, I am going to explain these things that why I define here. Further on, this is the LCD here. In the start of the code, I define the pins or assign the location of that specific sensor or component. So for the LCD, I define the RS, enable pin or these 4 data pins, and onward there are some VCC, VC which attach to 5 port and ground and so on. As per the library, liquid crystal for the LCD, it defines these pins goes here for the RS, EN, D4, D5, D6 and D7. Now the next thing here for the pins defined here is is of current sensor here. So for the current sensor, we only need one pin to get, as this current sensor is getting some data from this microcontroller and the further data is from the battery, so it can provide it how much current is running inside the whole circuit. Further on, we have, so there is one pin assigned and these are the analog pins here. Similarly, these variables are assigned to perform a specific function inside the code. So when I'm going to explain this function, I'm going to tell you that why I define it here. Further on, for the voltage sensor, I define a pin A2 here. This is the voltage sensor here, A2, analog pin. For the ultrasonic, above I define errors pins here. These pins here defined already above. But furthermore, I define the duration or distance. These are the variable assigned which used inside the function. So the functions come here. These are the basic functions which I'm going to use inside the loop. And when I'm going to use it, then I'm going to tell you about all functions. This is the setup here. As I already told you, first of all, I define the pins, which pins is assigned or to that specific sensor or component. Now further, I am going to assign that whether that pin is input or I am going to use it for the output. So for some, I'll assign input like IR sensor getting some input, detecting and get some input and get that input to the microcontroller. Further on, these are the four output output here as motor drive is getting the output. Further on for the trigger and echo, trigger is the output here and the echo is the input. Further on for the PNIs, this is the output here for the SD card here. So and so on. This is the LCD declaration. If I have to use the LCD has basically 2 rows and 16 columns. So we have to use all this, so we assigned it lcd.begin from their LCD library. And to start the LCD, we have used this in our code. Now the loop starts. This loop is for the line follower here. So let's get to the line follower. Where is the line follower here? This is the line follower here. So line follower have some condition. Let's get into it. When both stream right sensor and the left 4 sensor are going to on, then the report is going to turn right. Similarly, when the left 4 sensor on, it's going to move left. And the further, if the right to center left and center right is on, then it is going to move forward. And similarly, further conditions are explained that if all are going to be high or if all are going to be low, then the sensor is at stop state, that the robot is stop moving. And similarly for the stream 4 right, so here the thing is like that. I'm going to explain you like here. If I have to explain it, let me show you. Draw here. Is this here? Like if I have to, these are the 4 sensors here. 1, 2, 3, 4, 5, 6. So for these 4 sensors, whenever these 4 are on, these 3 are on, these 2 are on, or single side 1 is on, then we have to move left. But further on, if these conditions get reversed here, that these 4 sensors left 3, these and 1 is on, then we have to move the right. And the further on, the last condition here in our code is stated that if these 2 sensors are going to be on, or this is on, or this is only on, then we have to move the forward. So these are the conditions we define in our code here. The further conditions are not possible as for a simple arena. So this is all. Onward, it's going to be moved to the specific, as we can see, turn left function, turn right function, or stop function. For the turn right function, we have to do 2 things. We are assigning the PWM speed of both motors, but here we can see that we are providing all sensors low, but only the left motor have to be high. And the SD card data transfer here, that I am going to move the right. And for the turn left, SD card provides left, the left sensor, the right sensor is on, and so on. For the reverse direction, so the reverse direction is for the ultrasonic, or we can say for the obstacle here. Now I'm going to explain you about the codes here, like SD card. First of all, the SD card have to store some data inside it. So there are two things assigned to access it. For the first SD card access, we have to get some printed command. Now for begin the SD card, like we begin the LCD, we have to do it too. Now the SD card file is formed here. Further on, we have to store some data here. So we write this txt file path log 2.txt. So whatever data gets stored into this. And at the last, we are going to close the file here. Further on, this is the obstacle detector which I'm going to use in this ultrasonic. So let's get this ultrasonic first. That in the ultrasonic, I'm simply for the trigger low, trigger high, and trigger low and high conditions here. That if there is 3 centimeter away, the trigger is low. That no obstacle detected. But at the 15, it will detect it. And the sensor is going to be high, and some echo is or data is provided to the system that it have to move reverse and go back from where it comes. Now further on, the voltage sensor here. Voltage sensor is just that whatever the analog pin, this analog pin here, whatever this analog pins here get the data, it's stored inside this pin, and I'm going to perform a function like multiply by 5 and divide by 1023, because the data comes is in the form of analog and we have to convert it into a voltage value. So it converts the voltage value and we get that data here. As I use a voltage divider, I'm going to show it. We have not used a voltage sensor, we only use a voltage divider here. This is the V1 pin which connected to 12 volt of the motor drive which come from the battery. And further, there are two resistors 4.7k and 3.3k which use here to get that A to here. Further, we have a current sensor here. Current sensor is similarly like the voltage sensor, but here we use the sensor. So I'm going to use some logics to here. And after getting that ADC voltage minus offset divided by sensitivity, and sensitivity is provided. Further on, whatever the current value we get is in the form negative, so I'm going to convert into the positive value to show into the LCD screen, and it's returned. So to store it in the SD card or to store or display on the LCD. Further on, the LCD display here. So LCD display is here unsigned log millis. So millis function. The millis function is basically to avoid the delay in the code which stopped our motor. So we use different checks here. First, we set the LCD cursor or print RPM of one motor, then we set the RPM of second motor. Further, the mill is set for the current sensor here. So it is like that we have assigned different values, or we provided different things and so on, like RPM 1 shown here, then RPM 2, then the other check is for the current sensor, the next check is for the voltage sensor. So these are the 4 things which we have to show it on the LCD screen. Now the last final thing which I don't understand, is the encoder here. So here is the encoder performed here. In the encoder code, we perform the RPM. So basically how the RPM is getting here, it is like we have to count the sessions that how many times that loop cover in 1 second. In 1 second or in 1 minute, so we perform multiply by 60 and further 20 is the rex of the wheel, so it is divided by the count or number of cycle it performed. So by that I am going to get the RPM of that specific motor, and that specific motor RPM is going to be stored in the SD card. For the SD card I wrote the serial dot print here. That serial dot print here is going to be showed on the this serial monitor here. So this is the Arduino IDE code here. And further, this is the schematic circuit of our project here. This is Arduino, and further these all things are going to be connected to it. Voltage sensor, current sensor, voltage sensor, current sensor, ultrasonic, IR, U sensor. So these are the 5 sensors here. Further the SD card and the LCD card. It is for the display data, it is for the storing data, motors to work for that data. And these are the extra supply pins in our code that if we need some VCC supply or ground, so I'm going to provide it by here. So this is the PCB design here. I'm going to show you the 3D visualizer, so we have a proper view of it. These are the two resistors here, and this from here we provided the 12 volt, so we get the input here. Voltage sensor here. Further for the LCD, these two things are provided for the IR sensor. This is for the SD card here, for the UV sensor. Similarly for the motors, these are for the encoders here. So we perform as like the circuit designing is not that much difficult, because we have to only assign the pins here and we have to attach it to our sensors. The main major hard thing is the hardware, which I am going to show you at the end. So that's all for this phase. Thank you.
हमने स्टॉप बटन लगाया हुआ, इसमें बटन लगाने की जगह हमने क्या किया, इनकोडर्स के साथ कनेक्ट कर दिया उसको, और जब एक व्हील कंप्लीट रोटेशन कर चुका होगा तब वो ऑन होगा, वरना उससे पहले हमें मैनुअली करना पड़ेगा, उससे पहले कोई कंडीशंस नहीं फॉलो करेगा। इस पर कोई कंडीशंस नहीं फॉलो कर रहा, इसको हमने एक कंप्लीट रोटेशन दे दी और अब ये कंडीशंस को फॉलो कर रहा है। ये शॉर्ट स्टॉप था जो इनकोडर्स इंटरप्ट पे कोई कर। अब इसका अल्ट्रासोनिक सेंसर, ये आ गया ऑब्स्टेकल, ये आ गया ऑब्स्टेकल और ये रुक गया।
अस्सलाम वालेकुम सर, ये हमारा अभी स्टेट कंडीशन पे है, ठीक है। अभी कोई मोटर नहीं चल रही, तो ये 0 आरपीएम शो कर रहा है, ठीक है। और करंट जो है वो 0.62 आ रहा है। बैटरी हमारी अभी फुली चार्ज है, तो करंट हमारा जो है वो एम्पेयर में हमने चेंज किया हुआ है, ठीक है। तो यहाँ पे जो है वोल्टेज जो है हमारा वो अभी फुल चार्ज है, तो 11 आ रहा है। अब ये है कि हम लोग इसको देख लेते हैं। जैसे कि हम यहाँ से वायर उतारते हैं तो हमारा वोल्टेज जो है वो 0 हो गया, ठीक है। अब हम इसको वापस लगा देते हैं।
ये नहीं आ रहा।
अच्छा, ये अब दोबारा वापस लगा दिया, तो ये दोबारा वही वोल्टेज आ रहा है, ठीक है।
आरपीएम की वैल्यू
सही है। अच्छा, अब ये इसकी लाइन फॉरवर्ड की कंडीशन, अच्छा ये अब इसकी चेंज करते हैं कि जैसे यहाँ से अब हम लोग देते हैं कि अब दोनों मोटर्स तो इसके चलना चाहिए, ठीक है। दोनों मोटर चल रही हैं, ठीक है। ऊपर से आरपीएम भी दिखाओ।
7 आरपीएम की वैल्यू दिखाओ। एक ही मोटर चल रही है तो सिर्फ उसी का आरपीएम शो हो रहा है।
अब देखो, अब दूसरी का हो रहा है।
अब दूसरी मोटर ऑन कर दी, उसका आरपीएम शो हो रहा है।
अच्छा, दोनों ऑन करता हूँ।
अब दोनों ऑन है।
2 मिनट। ठीक है। और इसके अलावा अब यह है कि जब ये चलेगी, जब मोटर एक चलती है तो करंट बढ़ता है, वो दिखा दिया।
दोनों का आरपीएम इकट्ठे नहीं आया, दोबारा कर दो।
आ रहा है।
हाँ, दोनों मोटर का आरपीएम शो हो रहा है।
हाँ, दोनों का आरपीएम शो हो रहा है।
करंट की वैल्यू भी बढ़ गई है।
ठीक है।